How much do we perceive geometric features, personalities, and emotions in avatars? The authors are Vitor Araújo, Bruna Dal Moro, Rodolfo Favaretto, Felipe Villanova, Angelo Costa, and Soraya Halpmus. Our affiliation is PUCRS Brazil, and I am Vitor Araújo. Human behavior in crowds is a topic that attracts many scientific interests. In literature, there are works that involve visualization and analysis of cultural features, emotions, personality traits, perception of the impact of a group of characters on crowds, perceptual analysis of cultural features in agents with body expressions, and among others. Lately, studies have used geometric features to analyze cultural features in crowds. In work by Favaredo et al., the authors used group behaviors extracted from real videos to detect cultural features according to the Hofstede Big Five personality model and OCC emotional model. With that, we rise into questions. Can people perceive geometric features in avatars? Can people perceive cultural features in virtual humans without body and facial expression? With this, our goal is investigate how people perceive geometric, for example, density levels, distances, angular variation, and speeds, and cultural features, for example, personality traits and emotions, in avatars, virtual humans, and cylinders, without body and facial expressions. Our focus is on the perception of information based on space and geometry. Even when we investigate emotion and personality, we are interested in pure geometric manifestations. Thus, we used the videos from the Cultural Crowds dataset by Favaredo et al. We used tracked positions to animate avatars. We generated short videos of avatars representing the geometric and cultural data, and we asked people to answer questions about this data. Ocean is the most commonly used personality trait model for this type of analysis, also known as Big Five. The OCC emotion model indicates the inclination of each five personality factors to feeling every emotion. Young et al. Conducted a study analyzing perception to determine the impact of groups at different densities using 2 points of view, top and first person. The Cultural Crowd dataset and GeoMind model by Favaredo et al. Provide values for position, speed, angular variation, isolation level, socialization level, collectivity, ocean factors, and emotions for each pedestrian. With that, we create a viewer in the Unity 3D engine to reproduce all the obtained data. This viewer has three modes of visualization or viewpoints: first-person camera or first-person view, top camera, and an oblique camera. Pedestrians are represented by a humanoid avatar with three animations: idle, walk, and run, or a cylinder. Here we can see the three viewpoints used in our work. For example, on the left we can see the top view. In the middle we can see the oblique view. And on the right, we can see the first-person view. The videos used from the dataset depended on what feature we wanted to show. For example, if you wanted to ask about density, we could choose videos with different density levels. We divided the questions into two parts: to assess perception of geometric features, using two types of avatar and three viewpoints, and to assess perception of cultural features, using the humanoid avatar and the oblique camera. The entire questionnaire was assembled on Google Forms and transmitted on social media. 73 participants, 47 men, 28 women, 49 were under 31 years old, and 36 had at least an undergraduate degree. These are the questions about geometric features. 5 questions about density, 5 about speed, 5 about angular variation, and 4 about distance. Correct answers are highlighted in bold. Most questions had no difference as correct answers. This was done because we wanted to know if avatar types and viewpoints influence the answers. For example, density questions D2 and D3 represented three short videos with the same density levels, but with different types of viewpoints. So if the person answered no difference, we would know that the density was the same. We also had control questions. For example, in D1 and D5, we presented short videos with different density levels. There were 7 questions about cultural features. Q7 was added during the participant answer process. Analyze the partial results. Believe that the word extroversion was not being understood by the participants. So we created Q7, which had 25 out of the 73 answers. Correct answers are also highlighted in bold. Before each question, we presented a short video with humanoid avatars in low density. Which of the videos had two avatars highlighted in yellow and red, each having opposite values of cultural features? So people had to choose the avatar with the question feature. Here we can see an example of one of the short videos presented in cultural features questions. In the example, the pedestrian or avatar in red has a low sociability score, and we can see that he walks away from the group of people, while the pedestrian in yellow walks with other people. In this case, we asked people which was the sociable avatar, the red or the yellow one. Regarding our results, we performed statistical analysis, paired and independent test, and logistic regression, and we used a significant level of 5%. About geometric features, density, speed, angular variation, distance, all features were more correctly perceived by participants over 31 than participants under 31. Angular variation feature was perceived more correctly by women than by men. Distance feature was perceived more correctly by the undergraduate participants than by the non-undergraduate ones. Women perceive more correctly about geometric features than men. About cultural features, women perceive more correctly openness than happiness and extroversion. Men perceived neuroticism, anger, and fear more correctly than happiness and extroversion. Participants under 31 perceived more correctly neuroticism, anger, openness, and fear than happiness and extroversion. Participants over 31 perceived more correctly openness and fear than extroversion. Non-undergraduate participants perceived more correctly openness than extraversion. Undergraduate participants perceive more correctly neuroticism, anger, openness, and fear than happiness and extroversion, and also perceived more sociability than extroversion. Women and men perceived cultural features similarly. In general, the participants perceived more correctly neuroticism, anger, openness, and fear than happiness and extroversion. About geometric features versus cultural features, participants perceived more correctly cultural than geometrical features. About final considerations and future work. Regarding our first research question, the averages of right answers had low values, which implies that different types of camera and avatars influenced the perception of geometric features. Regarding second question, in most cases, participants had more right answers, averages greater than 0.5, which may indicate that people can perceive cultural features in virtual humans without body and facial expressions. For future work, we intend to assess whether different characters, for example, different genders, interfere the perception of cultural features. So these are our references used in this presentation. and thank you for your attention.